Good evening. What I'm going to try and do in this video is just describe what I did as far as a differential for the 32nd scale RC cars, conversion of a 32nd scale slot car to RC. So when I started, I was converting an HPI RS32, long since discontinued. Basically, I just rebodied it. And you can see here it had a differential, very smooth differential, gear differential. The cars are no longer available. The differential is no longer available. So, can't use that. So what I've done is I've built my own differential here. It's also, well, once it's tuned in, which this one's not, it's about as smooth as the HPI. It works very nicely. Worked out better than I could have hoped for. It has actually quite a number of advantages over the HPI differential, as well as anything else you can buy. But before I describe how to build this, which is what I'm going to recommend if you wanted to convert a slot car, I need to first explain that as far as differentials that you could buy, you can buy a Mini Z differential. This is a Mini Z differential I bought a lot of years ago. And it is very smooth, and it's very nice quality, and it works even for the 32nd scale cars. I have not modified it at all. It would still fit in the Mini Zs, but you can see here that the shaft sticks out too far on both sides. I would need to cut off the shaft to make it really fit into the 32nd scale car. In addition, it takes up quite a bit of room this way, more than I would like in the 32nd scale car, and it's a little bit heavy. I thought the weight might prevent it from, might slow the car down, but it really doesn't. It still works, but it is heavier. It takes up a lot of room, and this one was quite expensive. I bought one off eBay that wasn't quite as expensive. This doesn't have the gear in it, but basically it's another Mini Z ball differential with the gear and the balls are out of it. But basically this one was more on the range of $20 to $30. It was not smooth enough. It didn't work. So if you buy a Mini Z differential, my recommendation is you may need to buy one of the more expensive versions if it's going to be smooth enough to work in the 32nd scale. And then you're going to end up shortening the shaft so you can't go back and use it for the Mini Z. I decided to build my own because it's a lot less expensive. It's hard to spend $50 on one part for a 32nd scale car, which I think is what I spent for this, and that was even several years ago. Excuse me. I think I spent that for this one. Okay, so that's one way to go. You could buy a ball differential for the Mini Z, cut the shaft down and use that. But what I would recommend would be building your own differential like this. And maybe this is a good place to just stop and say you need a few tools. For me, building a car from essentially the only thing that I've used is the body and the tires. So everything else is I designed and 3D printed, which means you need a 3D printer, and you need not to be afraid to go into your favorite design tool to design your parts. I used the Ender 3 S1, not the Pro, but just the S1. I paid $280 a few years ago for that printer. It's been an indispensable tool to do this kind of thing. I think they're now selling for much less than that, maybe close to $200. I changed very few settings. Pretty much everything I've showing you is just stock as it comes off that printer. And you're also going to need a CAD tool. I use Fusion 360. You're going to find a lot of people that do this kind of thing use Fusion 360. I think it's easy to learn. It was easy to learn for me. And also it doesn't run out of steam. When you're trying to do something complex, you won't run into a brick wall with it. It will get you there. I didn't want to put a lot of work into something and then find that the CAD tool just wasn't able to get me there. The one other tool that you're gonna need to build this differential is a 256 tap, because I tapped the tubing in the process of building the diff. So now what I'd like to do is just show you the differential. So the first thing is take the body off the car, and you can see how similar this car is to this one. They're nearly identical. This one is actually for a Chaparral. This one's for a Lola T70. Something to say about the chassis. I don't understand how to make a universal chassis that fits every 32nd scale car. But you can see that they change in minor ways from one to another, chassis-wise. The front end and the differential are all identical, so there's a lot of design work in the front end and the differential, and all of that is identical between all of the cars that I've built so far. I've converted 4 slot cars so far, and so the differential is identical between them. The front suspension is identical. The wheels are not. The wheels need to be designed to the car, because if you look in the slot cars, every slot car, the wheels are different. They're correct to the prototype. So you need to model your own wheels. Okay, so to explain the differential, first of all, one wheel just pulls straight off, like so. On the other side, the wheel pulls off as well. In this case, I have 2 little shims that I 3D printed. There's one of them. There's the other one. These little shims, the only thing they're doing is spacing this wheel. I guess I could have printed the wheel so that it would have been in the right position without the shims, but the shims just let me move the wheel out just a little bit this way because it was too far in. They don't really have anything to do with the differential, and what I want to do is limit this video to just explaining the differential. So the wheels and these little shims, let me get them out of the picture. So we're just talking about the differential. Let me pull the differential out of the car. So this is the differential, and well, you can see the differential action. I turn the shaft one way while holding the gear, and this part, which attaches to the wheel, so the wheel goes the opposite direction from the direction I'm turning. and that's basically the differential action that you're looking for. So the way this works is the shaft does not directly turn, the gear does not directly turn either of the wheels. The wheels, both sides of the wheels, the torque is transmitted through these steel balls that are pressed between two metal washers. One metal washer here and another metal washer on this side. One other critical component, there is a ball bearing in here, which lets you, the function of the ball bearing is that when you push against this O-ring to apply some pressure on the steel balls, you also have pressure of this part against whatever's holding everything in, and it wouldn't move smoothly unless you had that ball bearing in there. But the ball bearing allows you to put pressure on the balls and still have everything move freely and get the differential action. So, only thing left is to take it apart and show you the parts. So, there's a pin right here, and the pin is, all I did was I cut, I think it's a 30 thousandths pin, and all I did here was cut a paper clip. Yeah, 30 thousandths. Some paper clips are a little fat, the larger ones. The normal sized paper clip, that's what this is, just a normal sized paper clip. And okay. So that much of a paper clip is the first part, first pin. And I'm going to mention right off that this differential, you can't, without a lathe, I couldn't build the shaft. That's critical to the design of this differential. I needed a straight shaft, and to get one, basically I used pins instead of outside threads and varying the diameter of the shaft. So a key to being able to build this was to use aluminum tubing that I could easily cut and drill through, and then keep the shaft as simple as it can be. It's just a straight shaft. Okay, so the first part, your first 3D printed part, there are only 3 3D printed parts, and this is the first one, and as you can see, it's not very complicated. It's just like a little washer or a shim. My idea was to, by varying the thickness of this shim, I vary the pressure on the balls. As the shim gets thicker, it squeezes the balls tighter. So this is primarily what I'm suggesting to use. And I printed several different thicknesses of this and just found which one gave me the smoothest differential action. So next is the O-ring. And at the end of the video, I'm going to show you exactly what I bought here on eBay and prices. And next is your second 3D printed part. And you can see here, it also is not a complicated part at all. It basically, let's call this a washer retainer. It's the washer retainer on the O-ring side. You can get all the dimensions. Once I show you what washer I bought, you pretty much can see exactly how to design this part in Fusion. That's your second part, and it also is pretty darn simple. Then there's a gear. Fortunately, well, okay, now there's another pin. This pin, if it's not there, the gear won't be able to, well, you won't transmit any torque through anything. The pin actually connects to this washer retainer, and so when the pin is in there, this washer is going to connect with the shaft. The motor, of course, drives the gear, and the gear transmits torque through the balls to both of the shafts, or excuse me, both of the washers. One washer drives the shaft, and this pin is the magic there, and the other one is just the balls drive the other washer, which directly connects to the other wheel. So let's take this pin out, and now take the gear out. Okay, now the gear looks like a complicated part. If I could have purchased this gear, I would have, and then I would have drilled the holes and put the detail in. I could not find this gear. So I needed to 3D print it. The other thing to notice here is that this gear carries this detail here, which is sized so the pin will slip through it. But when the thing is assembled, the pin actually does not engage with the gear. It engages with this slot. Having this detail in the gear makes it possible to slip the gear over the pin if you are assembling it from this direction. You can assemble it from the other direction, in which case I could have just had a simple hole in the gear. I wouldn't have needed the slot. And the most complex part you'd need to actually 3D print would be the washer retainer on the other side, which looks like this. And what makes it a little more complicated is it carries the bearing. So here's a cutout here, and this bearing, the bearing fits in there. Let's see if I can press it in. Okay. Yeah, so there's the bearing, fits down into there. And when this part goes over the shaft, this pan head screw on the end of the shaft it hits the inside race on that bearing. And so even if you have pressure against the washer, the shaft can still turn smoothly. The bearing is not a thrust bearing, but it is acting as a thrust bearing. That's what it's doing. And the last part in this whole thing is this screw. I've used here's the screw. There's the screw. There. I used a 1/8 inch long pan head 256 screw. It might have been better form to use a 1/4 inch screw. A flathead screw would work just as well or better. I didn't have a flathead screw. I didn't have a 1/4 inch screw. I just found this in my bag of screws, and so that's what I ended up using. So that's it. Fortunately, Fusion 360 will create the gear for you, and if you don't know where to find that in Fusion 360, you can just Google how to make a gear in Fusion 360 and it'll show you exactly how to do that. I should probably say that this gear is 48 teeth. It has a modulus of 0.4. It's easy to find 0.5 modulus plastic gears on eBay. 0.4 modulus gears, it's much more difficult to find them. I don't think that you're going to be able to do 0.5 modulus gears at the 32nd scale. Although 0.5 modulus gears, that's what Kyosho uses, that's what's common, and that's what works very nicely in 24 scale, but it doesn't work so well in 32nd scale. So you need a modulus 4 gear. I used a pressure angle of 20, whatever that means, in Fusion 360. So that's it. 48 teeth, pressure angle of 20, modulus 4, and you can work out what the circle these balls are set in is and how big to make the cutout. These are 1/8 inch ball bearings, I'm pretty sure. .125 inches. Okay. So, assembling this. We took it about one way. Let's assemble it from the other end, which I think might be easier. I'm a little unsure. But the first hole that you come to is to retain the little shim or washer. And then the O-ring. And then next would be this pin that's going to connect the shaft to one of the washer retainers. This washer retainer. The washer goes toward the gear side like this, and then one thing okay. I was losing a pin. So one thing that I can see, but I don't know if you can see very well, is that that second pin in there is retaining is connecting the shaft to the washer. Next would come the gear. If I put a little diff lube in here, which I certainly could have, the balls would stay in a little better. I didn't do that. And then last part here, and the shaft is barely through the bearing. And now to lock everything in, I need to put the screw in. If I were doing this, I think I'd use a vise to hold this because it's a little more challenging to do I got it. There we go. Okay. And then hold the gear and make sure I'm going to get the differential action I want. There it is. That may be a little loose. That feels right. Okay, so that's it. So, cost about $3, but the thing is, if you can't even, I don't even think you could buy just exactly the right amount of parts to just do one differential. So I ended up buying enough purchase parts to do 10 differentials, and it was about $32. So you can do, after you've bought the parts, you have enough purchase parts to do 10 differentials. And if you're going to do one differential, it's going to cost you $32. And if you're going to do 10 differentials, it's going to cost you $32. You have enough purchase parts to do 10. Okay. So, something that I always, if I watch an internet video like this, I always want to know exactly what to buy. So here's what I bought. So if you wanted to use the longer screw and a flathead, this is one you could buy. I found this at Macro Fasteners, I guess. If you type in exactly this into your search bar in Google, you'll find this. This is not what I actually had on hand, so it's not what I just showed you, exactly what I showed you. I found on eBay for $5, and that ought to give you all the information you need to find that. That's the 1/8" panhead screw. The washers were difficult to find, and they're not perfectly sized, but they don't need to be. They absolutely work. There are 20 of them, enough for 10 cars, 10 differentials. And I found these. I think you need to type in that UXCELLM1M8304. Type all of that in and you'll find these guys. So the next couple are all eBay. So these are the bearings, MR63ZZ bearings, and there's 10 there. Only one needed per differential. Steel balls. See if I can. There we are. $3.72. You get 100. That's way more than you need. You can end up with some spare parts. If you built 10 differentials, you'd use 60 of the 100. These are 10 O-rings. Again, this was eBay. Here's eBay. And I guess that's what you'd need to type in to find this on eBay. The tubing, you can buy it straight from K&S. It's K&S 3mm aluminum tubing. Let's see if I can show. I think that pretty much shows it. This was not eBay. Let's see. This was actually on the Midwest Model Railroad, is who sells these two tubes of it, or two pieces. Each piece will do about 5 cars, so this is enough to do 10 differentials. So basically that gives you a means of building a 30-second scale differential with 3 pretty darn simple parts to model. But of course you need a 3D printer and you need some type of a modeling software. Fusion 360 is free and it does the job. I guess the only other thing to mention here is just like this Mini-Z differential, Mini-Z is about 27 scale, let's just say 24 scale. So this will do 24 scale cars, but now it'll also, this is a 32nd scale chassis, it'll also do 32nd scale cars. And in the same way, this differential will do 24 scale cars with no changes to the design at all. So basically, if you have Mini-Zs and you want a 3D and you want a differential for them that costs $3.20 instead of a differential that costs $30 or $50, this might be the way to go. The most powerful Mini-Zs with brushless motors, I don't have any of those. I have like 10 Mini-Zs with the regular stock motors, and the 24 scale cars that I'm basically converting, I use the Mini-Z motor and the Mini-Z gearing, and that's why I know this would work for Mini-Zs, as well as the type of car that I've got it in is like this one. This is a 24 scale car. You can see it's the same differential. 24 scale car. It looks a lot like the (32nd) scale car, but you can see that the wheel based on the 32nd is definitely smaller. There's a difference between a 24th scale car and a 32nd scale car. And as I say, the differential in this car is exactly the same as the differential in this one. In the 24 scale, I'm using modulus 5 gears, and in the 32nd scale car, I'm using modulus 4 gear. You can see how similar the cars are. In the 24 scale car, I've gone to a more conventional servo. 32nd scale car, I'm using a Blade Nano servo, which I'll describe in another video. This one was supposed to be just on the differential, and hopefully I explained the differential adequately. Okay, I think that's everything I can think to say, and I hope that that's enough. If anybody out there is interested in doing a 32nd scale slot car conversion to RC, they know how to do the differential. Really, when it comes down to it, if you can do the differential in the rear, and you can do the front suspension, so you got to have steering, and you need basically a working suspension in the front, then you pretty much got it. All it takes from there is fitting the electronics and what electronics to to use, and that'll be subject of another video. Thanks for watching.